Alright, so we're going to show you how to solve a system of equations using an inverse matrix. So there's a couple steps that you have to do. First of all, you need to get the inverse matrix of this coefficient matrix. So this coefficient matrix is 1, 2, 3, 4. And the inverse matrix happens to be minus 2, 1, 3 over 2, and negative 1/2. And then what you do, you multiply by another matrix formed with these two numbers, so 8 and 6. Now, don't confuse this one with division. This is not dividing. It's not 8 over 6. It's just the matrix with 8 and 6. Now, what you do then, you multiply these two matrices, and then you will get minus 10, 9. You get another matrix. So this is going to be your x, and this is going to be your y, and that's it. Now, that is how to do it. So let me give you the proof now. Why is it true? Let's do it step by step. Okay. What I do now is I'm going to get the coefficient matrix. So that's what you do: 1, 2, 3, 4, and then that's the coefficient matrix. And then we get we separate the x and the y. So x and y. So this is basically extracting the coefficient matrix into one matrix, and then the variables go into another matrix. And you can multiply this matrix times this one, and you'll get back to the same thing here. All right, and now the right side, we turn the results into another matrix. So we're combining everything into matrices. Okay. So that's what we have right now. So we can do some. We can assign these ones to variables. Instead of working with this whole thing, I'm going to say this is A. And this array, this matrix, I'm going to call just X. And this array or matrix, I'm going to call B. Now, I'm going to multiply both by the inverse. So if I multiply this one by the inverse and this one by the inverse, okay, I get that. And you know that if you multiply two numbers, two matrices that are inverses of each other, then you'll get the identity matrix, which is I2. So now I have I2x equals A inverse B. Now, remember the I2 is the multiplicative identity. That means any number multiplied by I2, you're going to get back the same number. So this is equal to x. And now, so now I have x equal the inverse, times b. And remember that x actually represents here we go again. Represents a matrix with elements x and y. So it's equal to what we did before is the inverse matrix, which was minus 2, 1, 3 over 2, minus 1/2, multiplied by the matrix 8, 6. And so we said we got 10, 9. So now we say x equals 10 and y equals 9. So this is basically the proof of how this is. So to recap, I'm going to put in red. So you put your variables like this. And then you multiply the if your equation has x and y, has variables. So you put your variables, and then you multiply your inverse matrix. In this case, it was minus 2, 1, 3 over 2, 1/2, and then you multiply by the matrix formed by the results of your system equation. In this case was 8 and the 6. And so when you multiply this, you're gonna get another matrix, which is is going to be corresponding to the x and y. So now x equals -10 and y equals 9.